All right, let's solve another question involving a mass spectrometer. This time it is question 181. Let's read the question. So question 181. In the mass spectrometer shown above, a particle is accelerated through the potential V and then enters a magnetic field B. What is the radius of curvature? So in this question, we simply need to find a formula for the radius of curvature with respect to the voltage over here. So we have two plates. We have a particle. It's being accelerated through the two plate. It accumulates a voltage of V, and basically we will multiply the charge of the particle multiplied by the voltage to get the kinetic energy. All right. Then it has a certain velocity, enter a mass spectrometer, and because of the magnetic field, it starts a circular path and will collide somewhere on the screen over here. All right. So the first thing, we write the magnetic force is equal to the centripetal force. This is the part at the end. We know this, we can isolate the radius. So sine is again of 90. We're talking about the magnetic field here. For the angle, I mean. So the angle is the angle between the magnetic field and the velocity, just to be clear. We have the radius, we isolate the radius. It is equal to the mass times the velocity. Now note I added this little bar over here for the velocity because we have V for voltage and we have V for velocity. So just make sure we can distinguish between the two. So basically now we want to find the velocity, and in this case we assume that the particle accelerates from rest to a certain velocity. So at the beginning all the energy is in potential energy, so charge multiplied by voltage is our potential energy, and at the end all the energy is in kinetic energy, so 1/2 mv squared. We isolate the V, we get V is equal to square root 2 multiplied by the charge multiplied by the voltage. This V is a voltage, that's important, divided by m. At this point, the only thing we do is we replace the velocity over here by this term, and we end up R is equal to m divided by q multiplied by the magnetic field multiplied by the square root of 2 the voltage divided by the mass. There's also a simplification over here. If you square this side, if you square and square root this side, you can enter it inside the square root. Honestly, if you stop there, for me it's all fine. All right. So again, that's just a combination of two charge plate that is adding a voltage. We are going to be adding a velocity selector also in the next few example. All right. So let's solve some more example.